Hello friends, let's discuss one more example on trapezoidal rule. Let's recap the rule. Integral a to b y dx h upon 2 sum of the extreme ordinates plus 2 times sum of the remaining ordinates. So here is the question, integral 0 to 1 by 1 plus x square. Here the upper limit is 1, lower limit is 0. So h value will be b minus a divided by n, that is 1 by n. Now what I do is, if I take, say, n is 5, then width of each interval is going to be 0.2. So this interval 0 to 1 is divided into 5 sub-intervals, each having width 0.2. So it will be 0 to 0.2, then 0.2 to 0.4, then 0.2 to 0.6, 0.6 to 0.8, and 0.8 to 1. Note that width of each interval is 0.2. Now, when x is 0, y is going to be 1 by 1 plus 0 square, that is 1. When x is 0.2, y is going to be 1 by 1 plus 0.2 square, which is this. So each value of x, we are going to calculate corresponding value of y. Now this is 1 and this is 0.5. These become the extreme ordinates, and remaining entry is here. They are the remaining ordinates. So what is the formula? H by 2. H here is 0.2. So it is 0.2 upon 2 multiplied to sum of extreme ordinates. 1 and 5, these are extreme ordinates, plus 2 times remaining all the ordinates. So this plus this plus this plus this. So 2 times all these remaining ordinates. When you calculate, the value comes out to be 0.783732 approximately. Now, suppose somebody, instead of n being taken as 5, you might take n as 4. If n is 4, then h value will be 0.25. In that case, x will have values 0, next will be 0.25, next will be 0.5, next will be 0.75, and 1. So when x is 0, y is 1 by 1 plus x square, which is 0. So when x is 0.25, y is going to be 1 upon 1 plus 0.25 square, that is 0.94. So when x is 0.5, y is going to be 0.8. When x is 0.7, y is going to be 0.64. And when x is 1, y is going to be 0.5. So in this particular case, 0 and 0.5, sorry, this is not 0, it is going to be 1. 1 and 0.5, they will become sum of extreme ordinates. So in that case, integral 0 to 1 by 1 plus x square dx is going to be h by 2. H here is now 0.25 divided by 2. Sum of extreme ordinates, that is 1 plus 0.5 plus 2 times remaining ordinates. These 3 are the remaining ordinates. So 2 times 0.94 plus 0.8 plus 0.64. And when you calculate, the value comes out to be 0.7825. So this problem clearly explains how sensibly you can select value of n. So it is purely depending on your choice. I hope this comparative study makes the selection of n very much clear. Generally in problem, they give you the value of n. Remember, n is the number of subintervals. So how many subintervals are here? 1, 2, 3, 4 and 5. And here how many subintervals are there? 1, this is second, this is third, and this is 4. When we have 4 subintervals, then we have total 5 entries. And when we have 5 subintervals, then we have total 6 entries. I hope the trapezoidal rule is clear. Now, in exam, there can be some modification. They might give you this integral. They might ask you, evaluate this integral using trapezoidal rule. So either you can solve this way, or you can solve this way, or if they give the value of n, then you have to use that value of n which is given to you in the question. Now, one of the modification in this problem would be, they would say, evaluate this given integral using trapezoidal rule and hence find approximate value of pi. Now what you can do is consider this integral 1 by 1 plus x square dx, and you know it is tan inverse of x from 0 to 1, which gives you tan inverse of 1 minus tan inverse of 0, which is pi by 4 minus 0, that is pi by 4. Now this is value of integral pi by 4 according to the process of integration, and this is the value of same integral according to trapezoidal rule. These two values, this value and this value, can be equated. So pi by 4 will be 0.783732, and from here 4 into this, that will give you 3.13 approximately. So sometimes they ask you solve a problem and then they give you a little extra thing, like here in this particular case, solve this problem and calculate approximate value of pi. So what we did, we solved the problem using trapezoidal rule, then we solved the integral using normal method. So this normal value and this particular value, which is approximate, we compare, and when we compare we get the value of pi. I hope you understand the problem. Wish you all the best. Thank you. Bye bye.